Hello everyone, it's Shiyang.
It's Li. Welcome to our video.
Today, we'll make a brief introduction of optical communication. Before the technical part, we would like to pay tribute to a Chinese scientist, Dr. Carl Kun. He may be not as famous as Albert Einstein or Stephen Hawking, but his work eventually led humanity into the age of Internet, which is regarded as one of the greatest technological achievements in the 20th century, and earned him 2009 Nobel Prize in Physics. It is him who makes the optical communication the most shining star of modern communication, which however was almost given up because of the technological setback during that time.
As the father of optical fiber, his contribution to mankind is revolutionary. Optical fibers not only change the way of communication, but also change human lives in all aspects. Without optical fiber communication, there wouldn't be high-speed internet, mobile communication, social media, cloud computing, and video games.
Now, let's get started. First, let's talk about the basic concept of fiber optical communication, and we use optical communication for short. Different from traditional electrical media-based communication, optical communication system first converts the electrical signals sent by electronic devices such as our computers and smartphones into optical signals through the optical transmitter. Then the optical signals propagate in the optical fibers until they reach the optical receiver, which then converts the optical signals back to the electric signals again. Now the electrical signals can be recognized and processed by the electronic devices. So what are the advantages of optical communication? There are at least two advantages: distance and speed. First of all, compared to the electric communication, optical communication system is able to transmit over longer distance. Suppose 10 GB of information is to be transmitted in 1 second. If electric communication is used, the signal should be regenerated every 100 meters or so. In contrast, if optical communication is used, the regeneration interval can be more than 100 kilometers, making it much more economical and energy efficient. The second advantage of optical communication is that it can transmit massive amounts of information in a short period of time, often referred as information bandwidth. In 1 second, electric communication can only transmit around 10 GB information at most. In comparison, optical communication can transmit more than 1 TB information. Let's say you want to make a Google research, watch a YouTube video, store your photos on the cloud. They are powered by optical communication. And these are just some typical applications you can feel. Actually, from 5G to cloud computing, from data center to AI computing, optical communication is adopted more and more and has become the key ICT infrastructure in the era of artificial intelligence of things. Now, let's talk about the principle of optical communication. At the sending end, the parallel electrical signal information are combined into the serial electrical signal at high speed through the multiplexer, often called MUX. Why the multiplexers are used to pack in the user's electrical signals? This is because the bandwidth of the optical fiber is terahertz, meaning the optical channel is wideband. On the other hand, the bandwidth of the voice signals is 4 kHz, and the image signals is 6 MHz, meaning they are narrowband signal. The transmission narrowband signals on wideband channel will cause huge waste, so the multiplexers are used to make the most of the huge bandwidth from fiber channel. Next, the packed bundle of high-speed electrical signals needs to be converted into optical domain, where the electrical optic effect come into play. That is, electrical signals control certain property of the laser, and the optical intensity of the laser beam corresponds to the amplitude of electrical signals. This process is often referred as modulation. The modulated light is then sent out through the optical fiber. The modulation process is equivalent to the goods from the truck to the high-speed train. The signal is equal to the goods. The carrier is equal to the high-speed train. Then, the high-speed train with a large number of goods travel fast in high-speed optical. In the process of optical signal transmission in optical fiber, the waveform and strength of the signal are deteriorated gradually, so it is necessary to restore the waveform to its original form and increase the light intensity. If the waveform deterioration is severe, it is necessary to temporarily convert the optical signal into electrical signal again. After signal error correction in electrical domain, it is converted back into optical domain for transmission. At this point, the light signal reaches a distant station. The light signal is converted into an electrical current signal through the photodiode, using Einstein's famous photoelectric effect. The photodiode operates under a reverse voltage. When there is no light, the reverse current is very small and is called dark current. When the photodiode is illuminated, there is a reverse current, dictated by the intensity and wavelength of light. If a load is attached, a photocurrent signal is obtained on the load. Often signal processing is carried out in voltage domain, but the photodiode generates current. What should we do? Often the photocurrent is amplified by a special amplifier, which converts as well as amplifies the photocurrent signal into voltage signal. Since the conversion unit is impedance, and because the conversion is at different circuit port, this circuit is called transimpedance amplifier. The signal is then further amplified through the main amplifier, and then restored to its original form through the decision circuit and clock recovery circuit. Finally, the serial electrical signals is decomposed into parallel electrical signal and transmitted into the user through the demultiplexer. By name, we can see it's a reverse process of multiplexing, which we have already explained before. To make it clear, we can divide the whole optical communication system into two sides, the transmitter side and the receiver side. On the transmitter side, the parallel data are merged into a single high-speed data stream using a multiplexer. Electrical signals are generated by modulating circuits and laser diodes to produce high-speed optical signals, which are then transmitted over optical fibers. On the receiver side, the optical signal from the fiber is received by a photodetector, which produces a small output current proportional to the optical signal. This current is amplified and converted to a voltage by a transimpedance amplifier. The voltage signal is amplified further by a limiting amplifier. The resulting signal is fed into a clock and data recovery circuit. And at last, a demultiplexer converts the fast serial data stream into a parallel lower speed data streams.
Optical communication is a perfect combination between the integrated circuit design and the principle of communication. It is also extremely dynamic and challenging industry.
Welcome the smart view to join us and make the world more collective.